So in this video, we go over z-scores. Z-score is a great way to look at a data set that you are not familiar with and look for outliers or any unusual observations, even if you don't know the underlying data. And how you do this is that you standardize every score. So when you standardize, what you're doing is you're taking the particular observation, subtract the mean, and then take that value, divide by the standard deviation. That will standardize it, and that will give you a z-score. A z-score is based on a standard normal distribution where we would expect to get most of our data, plus or minus one z-score. Should be 68% of the data should be plus or minus one z-score. 95% of our data should be plus or minus two z's, and almost all the data should be plus or minus three. So anything, if you get a z-score that's over 3, that's a really high number. Or if you get a z-score that's less than 3, that's a really, really low number. So the z-score is based on something called the standard normal distribution. We will cover that later on when we talk about probability distributions, but it's good to introduce it, and I've built a little spreadsheet. I put it in, it's in the Chapter 3 data files under standard normal. And all this is, the standard normal distribution is unimodal, centered at 0. And if I put in, and so what it's the standard deviation is 1 on a standard normal, the mean is 0. But if I put in plus or minus 1, the area between that is 68%. I should get most of things happen between here. If I put in minus 2 and 2, that's 95%, and if I do minus 3 and 3, that's almost everything. That's 99.73%. So how can we use this? Because how do we generate these z-scores for a data set? Well, I'm going to go to this major salary. These are monthly starting salaries, and I don't really know what that underlying data looks like, but I'm going to convert these to z-scores. And to do that, I've got to do a couple things. I've got to calculate the average and get the standard deviation. The average, we already know how to calculate that. And then my standard deviation, use the .s formula. So there's the average, there's the standard deviation. So now I can calculate the z-score. And the z-score is equal to the starting salary minus the average, all that divided by the standard deviation. So for this first person, that's what their starting salary monthly was. The z-score of that is equal to, notice I'm using parentheses, there's order of operation issues. I take this salary, subtract the mean, divide by 651, and I get a z-score of minus 0.47, and that means it's really close to the average. In my graph, minus 0.47 is right around there. It's really close to the middle. Nothing abnormal about that. I expect to get that quite a bit. But now that I've got that formula, let me put some dollar signs around my references to my standard deviation and mean, so those are locked in. And that's too many decimal places. Let's only show a couple. Copy this down for everyone. And now, again, without knowing anything about this data, I can generate a z-score and look for abnormally high or low numbers. What do I mean by abnormally high or low? Anything approaching or bigger than plus 3 or smaller than minus 3. Now, that's a hard thing to do, but let me show you a little trick in Excel that you can use color. I'm going to look at this data, I'm going to highlight it all, and I'm going to go under the Home Conditional Formatting. So I'm actually going to format the cell based on its value. And I'm going to use a new rule. I'm going to use this first one, and I'm going to use a three color scale. And if the value, if I get something close to -3, I want the color to be dark red, and in the middle, I want it to be white. And then if it gets bigger than 3, these are all z-scores, I want that to turn red. So I'm getting varying degrees of red now. That's what I'm getting. So all I'm looking for is any really, really red looking stuff. So I could zoom way out if I wanted to look at it that way. And about right there is the only one, and that's a pretty high z-score. So this might be an abnormally high number or low number. That might be something that you would want to investigate. Why did they get such a high salary? Because that's a good thing. What should we do? It looks like in this case it was an accounting student. This number's a high one, and that was also an accounting student. Maybe that's good information that we can look at. You can always use it to do typos. So let's say that I've got this marketing person and I accidentally typed in 311. Let's see, what was the original number? 3180. What if I added an extra 0? Well, just like that, if I looked at the entire data set, that one turned way red because that z-score is going to be way less or bigger than 3. And that probably means, hey, there's probably something wrong with that. And sure enough, that was a typo. So let's fix that and put that back to where it should be. Okay, that's what z-scores do. They standardize data between hopefully plus or minus 3. If you get a number much bigger or smaller than that, that's probably something that you need to start looking at. Why did that occur? Because that's really high or low relative to the rest of the population. Thanks.